Okay, so industry first came up with LakeHouse architecture in order to bring the best of both worlds, data lake and data warehouse. And now they have come up with something more interesting, which is the LakeBase architecture. Now the LakeBase initially started with Databricks, and I'll get into the story of it as well. But this video is to understand what LakeBase actually means from the first principles thinking, as in from the architectural point of view, what problem does it solve, why do we actually need it, and again, even though this term was first coined by Databricks, from the architectural point of view, it is not just limited to Databricks, because Snowflake had also come up with something very similar just 1 month later. So this is Srinivas Vishnuprikar, and we will be talking about what LakeBase is from the first principles, and I'll try to keep this video really short. Also, this video is an inspiration from yesterday's Databricks user group meetup, where Sanket Kedkar and Ankita Darigar had given an excellent breakdown of what LakeBase is and its features. So this would be quite a similar talk in order to summarize what they taught us. At the same time, just talk things from the first principles thinking as well, and when should you actually leverage LakeBase architecture, whether it is in Databricks or it is in Snowflake. So let's first understand why do we need LakeBase in the first place. So I'll talk about the backstory first. So there was a company called Neon Postgres, and fun fact, Neon Postgres was founded by the original creators of Postgres itself, and it was acquired by Databricks in May 2025, exactly 1 year ago. And after that, Crunchy Data, which was again a managed Postgres database company, was acquired by Snowflake. If I'm not wrong, this was acquired at the valuation of $1 billion, and this was acquired at around $500 million, something pretty much similar. Regardless of the valuations, what mattered was these two companies like Neon Postgres and Crunchy Data offered really good leverage to both Databricks and Snowflake respectively. Now, what these acquisitions actually mean for big data AI platforms and customers as well. Let's talk about that. Now, every modern AI or data platform requires three things. First is the OLTP system, which is a transactional database, let's say MongoDB, Postgres database, MySQL, MariaDB, so on. Then we have some analytical platform, whether it is Databricks, whether it is Snowflake. Let's just say some Power BI like tool that is simply used for dashboarding purpose, whatever you call it. And then we have a pipeline that is actually acting as a bridge between this OLTP and OLAP. Now, what happened was, in this industry, they thought that this particular pipeline itself was a major, I would say, blocker. Blocker in the sense that it introduced a lot of latency, operational overhead, a lot of unnecessary complexities, and so on. So what engineers thought, let's just bring these OLTP systems into the data AI or analytical platform itself. So that was the base idea, and I'll also talk when this architecture actually makes sense. So that's how these companies actually started off acquiring these Postgres database companies. And why not? Because Postgres is the de facto relational OLTP platform, while being the most reliable and open source at core. So that's how these acquisitions started, and fast forward today, ever since that AI agents and agentic workflows has come into the picture, the latency has become a really big issue. So every time that AI agent wanted to access the real-time OLTP data, it would always travel through a particular pipeline, and at the end of OLAP or your data AI systems, your AI agents would access that data. And even if they had to access the OLTP data, it would use something, let's say, a reverse ETL, which is pretty self-explanatory, reversing the ETL. So rather than going from OLTP to pipeline to OLAP, now the data directly goes from OLAP to the OLTP. So that's the base idea. So this was again an operational overhead, a lot of complexities, again network latencies, and then they had to maintain two separate teams, two separate systems, and it was a mess, an unwanted mess at that. And not to mention, ever since OLTPs have gotten into these data AI or analytical platforms, data governance and security is also managed within these platforms itself. So something that was a really big overhead for engineers for a really long time, that was often not considered at first from the starting of the project development itself. Now this really big headache was also being solved. So that's the basic idea, and generally the use case revolves around the AI agents only. Not only, there are also cases where you would actually use OLTP within data AI platforms itself, and I'll also talk about that. So what approach does LakeBase actually follow? It is meant for speed and developer agility. And if you look at the features, they are really amazing. And the one that stood out to me was that git-like branching for databases. So you have databases, but now you want to make some changes. So rather than altering a database, you actually create a branch of particular snapshot. Then you make changes on those branches, and if they are working really well, you merge those branches into the main one, just like we do in Git for the code bases. So that was by far the most interesting paradigm shift for me. And then we have auto scaling and scale to zero. So let's say there are certain timelines where your database is not operational. In that case, why pay for that Postgres instance? You can simply scale it to zero. And not to mention, if your LakeBase had to spin up, it will spin up based on where we have configured it to run as soon as the query is fired, and it will just spin up within 250 milliseconds to 500 milliseconds. So within a second, if OLTP system is spinning up, just think about the underlying engineering that goes into it. So that was Databricks LakeBase, and now something similar that Snowflake came up with, as in making OLTP Postgres available out of the box in the Snowflake platform itself. They call it Postgres on Snowflake or Postgres Snowflake, whatever you are comfortable with. So their approach was a little laid back, I would say. They didn't focus too much on the speed and developer agility like Databricks did. In fact, Snowflake bet on something called as enterprise grade production readiness. So what does that mean? That it will not be used as extensively as AI agent heavy workload, but it will still reside within the vicinity of your Snowflake platform itself. So OLTP within the Snowflake's vicinity. And the features: high availability, automated failover, FedRAMP compliance, private networking, customer managed keys are just few of them. So by this video, you have already understood that making OLTPs a part of your data AI platform was not just another acquisition story, but rather a very strategic move for a statement that Sanket Kelkar really beautifully mentioned in his Databricks user group meetup was that in the needs of modern data AI systems, OLTPs and OLAPs will need to converge. And that's pretty much given because the way that our solutions and our problem statements are getting so much AI centric and AI agent driven, or at least accelerated, I would say. Making sure that your OLTP systems are available within the data AI platform itself eliminates a lot of bottlenecks, a lot of operational complexities. It reduces latency a lot because when these, let's say, Neon, Postgres and Crunchy data were acquired by Databricks and Snowflake respectively, obviously their underlying research and development and engineering team must have figured out some way to make these systems very much tightly coupled and integrated into these platforms itself. So that is something that R&D team takes care of, but we as engineers and product engineers, let's say, we are simply responsible for making sure that these features are leveraged when necessary at the best efficiencies at all times. So this was my breakdown of one of the most interesting application paradigm, and one of the key important things I would like to say is that data lake, data warehouse and lakehouse were more of the architectural solutions from the infrastructure point of view. But bringing in your OLTPs into the analytical or data AI platforms was not just an infrastructure move or a change, but rather an application perspective change as well. So that's a really important key takeaway. And again, it's not a compulsion to move your OLTP Postgres database. If you have Postgres, then it's not compulsion to move them into data AI platforms like Databricks or Snowflake. That's very subjective to the customer needs, the cost affordability, and whether your team is skilled enough to make this migration happen. And if that's the case, congratulations with your new migration project, and I wish you a lot of pipeline figures. So this was my simplest breakdown of what LakeBase architecture is. I'm really sorry if you must have heard some background noises of, let's say, a few dogs barking or children playing outside, because again, what else people will do on Sundays. So thank you very much. I hope you must have liked this video. Not liked literally, but you must have enjoyed this video. And if you have any feedback to share me or have any suggestions that I can do better while creating such videos, do let me know and I'll surely make that happen. This is Srinivas signing off. Bye bye.